Okay, so I know a lot of people struggle with recursion, but hopefully after watching this video, you'll find that it's no longer difficult. Um, so the way I like to teach it is you want to think of recursion kind of like Minecraft, right? So in the game Minecraft, you want to dig down into layers, and then you want to dig back up, right? So that's kind of the core idea of recursion. It's a bit abstract, but keep that in mind throughout the rest of the explanation. Okay, so let's say I have a recursive function, right? Like I have a recursive function and I want to reverse a list, right? And I get given a list, something like 1, 2, 3, and I want to reverse the list. So what I want to do is I either want to break the problem down as I'm going downwards, or I want to build the solution up as I'm going upwards, right? So when I'm going down, I want to break the problem down, right? I want to make the problem simpler. 1, 2, 3, there's all these elements inside. It's pretty complicated. So how can we make this simpler? So we dig downwards, but this time we pass in, instead of passing in the whole list of 1, 2, 3, we pass in reverse list, maybe something like just 2, 3, right? We remove the first element and we make the problem just that little bit simpler, right? And then we can call this function again. We call reverse list, and we pass in just 3. And then we call reverse list again, removing the head. And it's just on an empty list, right? So this is, we've reached the simplest possible state the problem can be in, right? It doesn't get any simpler than this. Empty list, literally very straightforward, right? So this is called the base case. So when we think about how to solve a problem recursively, this should be our number one priority. How can we solve the base case? Why is it our number one priority? Because it's nice and easy, right? Empty list, nice and easy, base case. First thing we should think about. So once we hit the base case, it's kind of like we hit the bedrock in Minecraft, right? We can't get any simpler than this, so we want to go back up. So as we're going back up, we want to build the solution. So remember, when we're going down, we want to break the problem down, and when we're going back up, we want to build the solution up. Okay, so as we're going back up, remember how we removed 3 in this particular layer? Maybe we'll reattach this 3 back into the list, right? We'll put the 3 back into the list, right? And as we're going back up here, you know how we removed the 2? So instead of putting the 2 back in the start of the list, which defeats the whole purpose of doing this, maybe we can append the 2 to the end of the list, right? So we build the solution back up, and then we put the 2 here. And then up here, you know how we removed the 1? After we remove the 1, maybe we can put the 1 back in, but like so instead, right? So this is the recurrence relation. So as we're moving from layer to layer, we are removing the head of the list, and then as we're going back up, we're appending to the list, right? So remember, again, as we're going down into deeper and deeper layers, we want to break the problem down, and as we're going back up the layers, we want to build the solution up. So this is the second step of recursion, which is the recurrence relation. Okay, so let's look at an example with a piece of code. It's a little bit abstract, but it will be a lot clearer. Okay, so let's have a look at this code. So this code corresponds to the whiteboard example I just did, and it's in Python. So here, a very, very useful trick for debugging recurrence functions is to do this. So you add a default parameter where layer equals 0. And then every time you call the recurrence function, you add layer plus 1. So what this does is, the first time you call this function, layer equals 0. And every subsequent time you call this function, you record what layer you're in, but with this plus 1. So, if you've called this function 3 times, you're in layer 3, and it helps with the messages you're about to see me do. But here we can add a print statement. So we do something like print f layer, layer, and we say something like, this is the base case, right? Base case, we return empty list. And then here we have the head of the list. So we say something like removing head, right? And here we have the simplified list, which, as I described, is breaking the problem down. So we want to say breaking problem down. And then here, after we call the recurrence relation, we can say something like, bounce bubbling back up. So referring back to this whiteboard, this process of going up is called bubbling. It's because bubbles rise to the surface, and here is a very important concept. So this very important concept is what I like to call the recursion theory, right? So when you call the function and you're trying to reason through the recursion calls, you don't want to try and imagine, inside this function, I'm going to reimagine this whole procedure again. And then inside this function, I'm going to reimagine the whole procedure again, right? You'll run out of short-term memory pretty fast, and it's not going to be very helpful, right? So when we say the recursion theory, what we want to do is we want to trust that this function does exactly what we think it would do, right? So instead of doubting it and trying to reason through what's going on inside here, we pretend it's a black box. Yeah. So we pretend it's a black box and it does its job perfectly. So when we pass in the simplified list, it does its job perfectly of reversing it. And then now that the list is reversed, we want to add what used to be the start of the list to the end of the perfectly reversed list, right? And then we want to return a solution. So to illustrate this, I have this example of a list from 1 through 5. So let's run this. Hopefully it doesn't crash. Yep. So I should probably print out what the list looks like throughout the process. Yep. So we can see here that when we start and run the function for the first time, it's too complicated. We have 5 elements in there. That's way too many elements. So we remove the head, and oops. Should be this. So we remove the head. Yeah. So we remove the head of the list, and then we're left with 2, 3, 4, 5. And then, we call the function again. So we we dig down, right? We dig into layer 1. And, it's still too complicated. We still have, 4 elements in our list. We don't want to think about complicated scenarios, right? So when we do recursion, we want to be lazy. We want to be a bit lazy, a bit dumb about how we want to solve the problem. So we come down here, and then we're like, okay, it's still too complicated. Let's just remove the head again, right? So we go into layer 2. And then inside layer 2, we only have 4 and 5. And it's still too complicated. So we remove the head again, 4. And then even when the list just has 1 element, at this point, I could have coded it so that this was the base case. But, let's just say even having a single 5 in it is way too complicated. So we remove 5, right? So now, at layer 5, we finally hit the base case, right? The list is empty. So when we hit the base case, we're like, oh, great. We know the answer now. The reverse of an empty list is just an empty list. So let's just return the empty list, right? So after we return the empty list, notice how this bubbling back up, the recursion fairy magically at every layer gives us a perfectly reversed list. So after we bubble back up 5, we bubble back up 5 to layer 4. And then at layer 4, we add the head back onto the end of the list. So it's 5, 4, And then after the 5, 4, we add the head at layer 2 back into the list, which is 5, 4, 3. So notice how at every layer, the reverse list, we just trust that recursion fairy did the job perfectly, and we slowly add to the solution, right? So we slowly build the solution up, and then at the very last layer, which is the surface, layer 0, we get back the answer we wanted, which is the reverse of the whole list. So the key to recursion is the understanding that across the layers, first you have to break the problem down, and then you have to build the solution back up. Sometimes you only need to break the problem down, and then sometimes you only need to build the solution back up. But this problem, I try to do it in a way that sort of illustrates both a little bit. So, so just to reiterate, the 2 important steps of recursion, the base case. So this is like, literally, what's the simplest possible input that you straight away know the answer to? And then you just code it in, like you just add an if statement in the function that's like, once this happens, just return this answer, right? And then you want to figure out the recurrence relation. And just to reiterate, the recurrence relation, there's 2 parts. You either want to break the problem down or you want to build the solution up. Or sometimes a combination of both, as in this example. Okay, hopefully that helps. And yep. Yeah, thanks for watching.